Alright, so for this video, we are going to discuss how to sketch the graph for exponential function and also the log function. Okay, so in the previous video, we already learned now what is the log for base e, right? So it's actually, we call it as natural log. Alright, so when we change it become the exponential function, it will be e power x. Alright, where x can be any number. Okay, then when you make the e power x into the log pattern, okay, the log function, then you will get log x. Log is log base e. And then you need to know that for the x inside the log, it must be always a positive value. If x is negative, then it's undefined. Alright, so you need to know how to change the exponential function to become the log function. So I think I discussed this before, like in the previous video already. And then you should know that these two functions, what's the relationship between these two functions? So they are actually inverse function of each other. So that means if let's say your fx is ex, e power x, and then your f inverse x will be log x. So they are inverse function of each other. And then since they are inverse function of each other, alright, so you should know that we learned some properties before in AS level, right? When you are having the inverse function for each other, what does it mean? That means that they reflect each other at a certain line, right? What is the certain line? At the line y equals to x. Alright, so this is some small details or small properties that you need to know. Okay, so let's start. Let's learn how to sketch the graph. Alright, so if let's say I'm having the function e power x, okay, so you actually should try to remember this graph. Alright, you should try to remember this graph. Okay, so for e power x, the graph will look something like this. Alright, so this is value 1. It will always pass through the 1. The y-intercept is always the 1 here. Okay, and then for here, this part, the graph will go very, very close to the x-axis, but it will not touch the x-axis. Okay, so this is the function fx equals to e power x. Alright, so I think you should remember this one. You should try to remember this because they will sometimes ask you to sketch it up, maybe in chapter 6 later. Alright, so it will be good if let's say you remember the basic shape of this e power x. Alright, then since it is the inverse function for log x, therefore when you want to sketch log x graph, you can actually draw a line first, y equals to x. Okay, then this point itself, when you write the coordinate, it will be like 1, right? So I think I teach you before, if you want to sketch an inverse function, you swap the coordinate. X become y and y become x. So when you're having x become y and y become x, that means you will pass through this one. So this one is 1. Alright, so it will be 1 and 0. Okay, then for the graph here, it is getting very close to the x-axis, but it will not touch the x-axis. So when you want to reflect it, get through the line y equals to x, that means that your graph, you're very, very close to the y-axis, just like x-axis now, right? So now it's y-axis, but you will not touch the y-axis. So that means your graph will come from this part, go up, pass through the 1, and something like this. So this is actually the graph for y equals to log x. Okay, so this is just a very basic graph for you to understand how to sketch the e power x graph and also the graph for log x. So in my opinion, I think the e power x graph is quite important. Log x is quite important also, but this one is more important, e power x graph. Alright, so log x, you also need to know the basic shape, okay or not? Alright, then now, if let's say you look at the red color part, color graph, what is the domain for the red color graph? You will see that the domain is from negative infinity until positive infinity. That means x is any number, any real number. And then for the range, for the red color part, you will see that it is actually above the x-axis, and therefore when you write out, you can write the range of f is actually y greater than 0. Okay, or you can write fx equals fx greater than 0. Okay, then now if you look at the purple color graph, y equals to ln x, the domain will be, what is it? X greater than 0. Do you still remember or not? The domain of f inverse, it should be equals to the range of f, right? So the range of f is y greater than 0. Therefore, you can straight away copy the value, but you change the y become x. Same thing happen for the range here. The range for the inverse function will be equals to the domain of the original function, and therefore your y can be any real number. Okay, so this is a very basic idea or concept that you need to know about the e power x and also the log x. Okay, so first you need to make sure that you remember this graph, e power x graph, and after that you also need to remember the graph y equals to log x, and then you should know that they are inverse function of each other. Okay, so after you know all these things already, basically I will want you to remember an important result here. Okay, so important result is when you are having y equals to e power x, all right, when your x is going to be negative infinity, you should know that your y is getting closer to 0, which is this one. Okay, this is the e power x graph, right? Okay, so when your x is going to be negative infinity, you will see that your graph getting very, very close to the x-axis, and this the value is very, very small. All right, but it will not touch the x-axis. So that means when you write it out, it will be y getting closer to 0. Okay, so this result, please make sure you remember it because we will use it in chapter 5, integration later. All right, so like chapter 5, maybe you will see something like this, e power x, and then they tell you I got 1 and negative infinity. So when you want to substitute the value 1 and negative infinity, right? So it will be negative e power 1 minus e negative infinity. So what is the negative infinity here? So when you substitute it, you cannot write it something like this. Okay, so you have to imagine that, okay, you substitute the negative infinity into the e power x, right? You should get a 0. Okay, then your final answer is e power 1. So this is where we use it in chapter 5 later. So this result is very important. Make sure you remember. Okay, so this is one of the results that we use it quite frequently. All right, so I will just want to remind you here first. Maybe you can copy down this one and then you try to recall back later when we go to chapter 5. Okay, all right. So to me, this part is important. The graph itself and also this result. Okay. Then after that, we proceed further to another graph. So this graph comparatively will be less important. Okay, but no matter how, we still learn about it. Okay, so now if let's say your function fx is e negative x, so when you are having e negative x, how will your graph look like? Okay, so if you are having e negative x, your graph will look something like this. Sorry, I need to draw it again. So the same concept is the graph will getting closer and closer to the y-axis, but it will not touch the y-axis, and then it will still pass through the 1. So this is really fx equals to e power negative x. All right, and then again, if you want to sketch the graph for the inverse function, we are using the same concept here. You're having the line y equals to x, and then this point itself again is 0, 1. So when you want to sketch the inverse function graph, it will become 1, 0. So 1, 0, maybe I just assume that it is here. Right, so this is 1, 0. And after that, your graph will pass through the intersection point, right? I told you before. Okay, and then what else? Okay, so you will see that just now, your original graph getting closer and closer to the x-axis at the positive side, but it will not touch the x-axis. So now the same thing happens when you want to draw the inverse function. So your graph will start from y-axis, positive y-axis, very, very close to the y-axis, but it will not touch it. So it need to pass through the intersection point, need to pass through the 1, 0, and your graph might look something like this. So this is your inverse function. So f inverse x, which is equals to negative ln x. Okay, so in my opinion, my suggestion is for this graph, these two graphs, right? E power negative x, it will be good if you can still remember it. All right, and then for negative ln x, to me, I think it's not so important. We seldom use it. All right, but for e negative x, maybe you can still try to remember it, because sometimes they will still ask you to put in the 6 later. Okay, then the same thing happens. What is the domain here? So if you have a look for the red color graph, the domain is x can be any real number. And then the range again, if you look at it, you will see that, oh, okay, the whole graph is above the x-axis. And therefore, the range will be y greater than 0. Same thing happens for the inverse function. So if let's say you are looking for the inverse domain of the inverse function, you can copy the range for the original function. So the domain for the inverse function will be x greater than 0. And then for the range, it will be y, can be any real number. Okay, so this is what we have for the very basic graph about all the exponential function for the natural exponential and also the natural log. All right, and then again, what is the important result from here? So to me, important result. Again, important result is when you're having y equals to e negative x, when your x is going to be a very large value, you should know that your y is getting closer to 0. Okay, so where we use it again, so the same thing happen. Maybe in the integration in chapter 5 later, after you integrate e power negative x, they want you to substitute the value from infinity to maybe negative 2, let's say. So when you want to substitute the infinity into the value, into the graph, you cannot write like this again. So you need to imagine in your mind that, okay, like e negative infinity. That means when you substitute infinity into the graph, okay, the value is getting closer to 0. And then minus e negative 2 become positive 2. So your final answer will be e negative e power 2. So this is the important result that you should know, because we'll use it also in chapter 5 later when you learn integration. Alright, so the graph itself and also the important result here, try to remember it. Okay, because you are going to use it in the future. Alright, so for now, maybe you didn't use it yet. Alright, but in the future you will use it. So I want you to refer back to this part. Okay, so this is what I want to cover for this video, that to discuss the use of the graph for exponential and the log function. Right, so for the next video, we are going to learn how to solve all the equation with exponential function and also the log function.